Okay everyone, now we're going to explore how gears work. Everyone has some gears in front of them, and I would like to know, can you work out how they fit together? Can you work out how they move? And can you put some together to see what you can find out about gears? We've included images here as a hint. Without them, the groups tend to make axles with wheels or spinning tops or anything but gears meshing together. Once the class has played with the gears a bit, ask them for feedback on what they have learned from their exploration. This may include, and should be drawn out during the discussion, the use of the word rotation, discussion of rotational direction, clockwise and anti-clockwise, description of gears fitting or meshing together, and a description of gears moving at different speeds when turned. Now that we have had a look at the gears, it's time to make our first gear train. A gear train is a system of gears which transmits motion from one shaft to another. To make a gear train, you will need an axle and a gear. When two gears are meshed together, this is known as a gear pair. Okay everyone, with your gears, can you make the two gear trains shown on the slide? When you are done, hold the trains above your head so that we know you are finished. Give the children a few minutes to put the gear trains together. Asking them to hold them above their heads has the added benefit that they will not be playing with the gears. Okay, now that we have our two gear trains, we are going to look at how a gear train moves and talk about gear ratios and how we can calculate them. A gear ratio is the ratio of the number of rotations a driver gear, which is also known as the input, to the number of rotations of a driven gear, the output. Essentially, we want to know how many times do we need to turn the red gear to make the yellow or blue gear turn one full rotation. In this animation, we have a copy of the gear train you have made. You will see that when you have two gears of different sizes, one rotates more quickly than the other. Let's let the video play, and can you count along with me? Now it's your turn. Use your gears to work out the gear ratios at the top of your worksheet. Remember, the gear ratio is how many times you'll need to turn the red gears a full rotation to turn the blue or yellow gear one full rotation. Give the children a few minutes for this task. Circulate around the table to check if anyone needs any help with understanding how to work out the ratio. Once everyone has completed the task, collect the answers from the class. Show the answers on the slide above and confirm the answers by demonstrating on the gears. You'll notice that we aren't using formal ratio notation to describe the gear ratios. For this session, it is enough to say that the red gear turns 3 times to turn the yellow gear once. Hence an answer of 3 for the yellow and red train. We've made this choice so that the session is accessible to as many children as possible. So now we know what gear ratios are and how to calculate them. Why might gear ratios be useful? Allow the children time for discussion and give them the opportunity to feedback answers. Answers might include, they can change the rotational turn and speed of the gears, they move location of the rotation. A particular good example of the importance of gear ratio is an analog clock. This section might be better if you want to tell or show the group why gear ratios are useful using an analog clock. Now that we have looked at a simple gear train, we are going to look at a compound gear train and coaxial gears. These trains are called compound gear trains as they have a number of gears meshed together. As you can see, the blue and red gears are fixed on the same axle. This is a coaxial gear, or we could say that they are coaxial. These are new pieces of technical vocabulary. Be sure to use them repeatedly throughout the session. Also try to provide the opportunity for the class to use them themselves. You know how to calculate a ratio on a simple gear train, and now we're going to look at how to calculate the ratio of a coaxial gear train. Our first red gear is the input gear, and the yellow gear at the end of the train is our output gear. So let's watch the animation and count along with me. Now it's your turn. Make the gear train shown in the picture. These trains are called compound gear trains as they have a number of gears fixed together. Use your gears to work out the gear ratios at the bottom of your worksheet. Remember, the gear ratio is how many times you need to turn the first red gear a full rotation to turn the yellow gear one full rotation. Give the children a few minutes for this task. Circulate around the tables to check if anyone needs help with understanding how to work out the ratio. Once everyone has an answer, collect the answers from the class. Next, show the children how we can work out the ratio of the compound gears mathematically by multiplying the ratios of the paired gears as shown in the illustration.